When dealing with cut-in boxes and rated walls, it's important to understand the requirements outlined in the UL Fire Resistance Directory, as referenced by NFPA 70 Article 300.21b. While this standard doesn't explicitly prohibit the use of cut-in boxes, it does emphasize the need for secure fastening to the studs. This requirement can pose a challenge when using cut-in boxes, as they are not typically designed to be fastened directly to studs. The Florida Building Code, or FBC, and the National Electrical Code, or NEC, may not offer specific guidance on the use of cut-in boxes in rated walls. Therefore, enforcing the UL requirements in these situations may depend on interpretation and the specific code enforcement practices in your local area. For penetrations of rated walls, it's crucial to remember that cables and conduits that pass through a firewall must comply with a UL system number or an equivalent approved fire-stopping system. These penetrations should be made perpendicular to the wall, and the space around the penetration, known as the annular space, must be properly sealed using fire-stopping materials. The application of these materials must adhere to the limits specified in the chosen system. A method of creating an angled or parallel opening and filling it with fire core typically does not meet these requirements. The fact that a cable remains within the wall cavity doesn't exempt it from the necessity of complying with the UL system or an approved fire-stopping method. Local code enforcement officials are vested with the authority to enforce the requirements of the adopted codes. This includes the UL standards when they are referenced within those codes. If the FBC or NEC lacks specific guidance on a particular issue, the code enforcement official may consider the UL requirements as part of the suite of approved methods for fire-stopping penetrations. When addressing these issues, there are several recommendations that you can consider. 1. For cut-in boxes in rated walls, consider having the contractor install surface-mounted boxes that can be securely fastened to the studs. 2. Require the contractor to implement a UL-approved fire-stop system or to meet the specific requirements of a defined UL system number for all penetrations. 3. It's important to verify that all penetrations are made perpendicular to the wall. Also, the annular space around the penetration must be thoroughly sealed with fire-stopping materials, adhering to the required limits as specified by the approved system. When selecting the right box, several factors need to be considered. Firstly, the box must be appropriate for the specific wiring method that is being used. For instance, if non-metallic sheath cable is being used, the box must be rated and listed for use with that type of cable. Secondly, the box must have sufficient internal space to accommodate all conductors, devices, and fittings that will be installed within it. This is to prevent overcrowding and potential overheating. Thirdly, the box must be securely mounted to a structural member of the building. This is to ensure that the box does not become dislodged or damaged over time. The NEC provides specific requirements for the selection and installation of boxes. For example, NEC Section 314.16 provides requirements for calculating the number of conductors permitted in a box. NEC Section 314.17 provides requirements for securing boxes to structural members. Furthermore, different types of boxes are suitable for different applications. For example, metal boxes are typically used in areas where there is a risk of physical damage, while non-metallic boxes are often used in damp or wet locations. The choice of box material should be based on the specific environmental conditions and the type of wiring method being used. Additionally, the size and shape of the box must be appropriate for the devices and fittings that will be installed within it. For example, a deep box may be required to accommodate large devices or a large number of conductors. The shape of the box should also be considered to ensure that it fits properly in the available space. Proper box selection is critical for ensuring the safety and reliability of electrical installations. By following the requirements of the NEC and considering the specific application, electrical contractors can select the right box for the job and ensure that it is installed properly. When dealing with the fire rating of walls, one must consider the specific hourly rating. This rating indicates the amount of time a wall can withstand exposure to a standard fire before structural failure occurs. Common fire ratings include 1 hour, 2 hours, 3 hours, and 4 hours. The fire rating of a wall is determined by a variety of factors, including the type of materials used in its construction, the thickness of the wall, and the presence of any fire protection systems. The fire rating of a wall is typically indicated on the wall itself or in the building's construction documents. It is important to select boxes and fittings that are rated for the same fire rating as the wall in which they are being installed. This is to ensure that the boxes and fittings do not compromise the fire resistance of the wall. Fire-rated boxes and fittings are typically made of metal and are designed to prevent the spread of fire and smoke through the wall. They are also typically equipped with intumescent materials that expand when exposed to heat, sealing off any openings and preventing the passage of flames. The NEC provides specific requirements for the installation of boxes and fittings in fire-rated walls. For example, NEC Section 314.20 requires that boxes and fittings installed in fire-rated walls be listed for use in such walls. NEC Section 314.21 requires that the inhalation space around boxes and fittings installed in fire-rated walls be sealed with a fire-rated sealant. It is essential to follow the requirements of the NEC and the manufacturer's instructions when installing boxes and fittings in fire-rated walls. This is to ensure that the boxes and fittings do not compromise the fire resistance of the wall and that the building's occupants are protected in the event of a fire. When choosing fire-stopping materials, one must select materials that are specifically tested and listed for use in fire-rated walls and floors. These materials are designed to prevent the passage of fire, smoke, and hot gases through openings in the fire-rated assembly. Fire-stopping materials come in a variety of forms, including sealants, putters, foams, and wraps. The choice of fire-stopping material will depend on the size and shape of the opening, the type of wiring method being used, and the fire rating of the wall or floor. Fire-stopping materials must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. For example, NEC Section 300.21 requires that the integrity of fire-rated walls, floors, and ceilings be maintained when electrical cables and equipment pass through them. This means that any openings around cables and equipment must be sealed with the fire-stopping material that is listed for use in such applications. It is important to inspect fire-stopping installations regularly to ensure that they are in good condition and that they have not been damaged or compromised. Damaged or missing fire-stopping material should be replaced immediately to maintain the fire resistance of the wall or floor. When dealing with cable types, such as MC cable, it is important to be aware of the specific requirements for their use in fire-rated walls. MC cable is a type of armored cable that is commonly used in commercial and industrial buildings. It consists of insulated conductors that are enclosed in a flexible metal sheath. MC cable can be used in fire-rated walls, but it must be installed in accordance with the requirements of the NEC and the manufacturer's instructions. For example, NEC Section 330.40 requires that MC cable be supported and secured at intervals not exceeding 6 feet. This is to prevent the cable from sagging and potentially damaging the fire-stopping installation. MC cable must also be protected from physical damage. This can be achieved by installing the cable in conduit or by using a cable tray. When MC cable passes through a fire-rated wall, the opening around the cable must be sealed with the fire-stopping material that is listed for use with MC cable. The fire-stopping material must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. It is important to select a fire-stopping material that is compatible with the metal sheath of the MC cable. Some fire-stopping materials can corrode the metal sheath, which can compromise the fire resistance of the installation. When dealing with conduits, the NEC provides specific requirements for the use of conduits in fire-rated walls. Conduit is a type of raceway that is used to protect and route electrical wires. It can be made of metal or non-metallic materials. Conduit can be used in fire-rated walls, but it must be installed in accordance with the requirements of the NEC and the manufacturer's instructions. For example, NEC Section 300.21 requires that the integrity of fire-rated walls, floors, and ceilings be maintained when electrical cables and equipment pass through them. This means that any openings around conduits must be sealed with the fire-stopping material that is listed for use in such applications. When conduit passes through a fire-rated wall, the opening around the conduit must be sealed with the fire-stopping material that is listed for use with the conduit material. The fire-stopping material must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. It is important to select a fire-stopping material that is compatible with the conduit material. Some fire-stopping materials can corrode the conduit, which can compromise the fire resistance of the installation. When choosing the correct annulus space for cable and conduit penetrations, it is important to understand that the annulus space is the gap between the cable or conduit and the edge of the opening in the wall or floor. The size of the annulus space is critical for ensuring the effectiveness of the fire-stopping system. If the annulus space is too large, the fire-stopping material may not be able to properly seal the opening, allowing fire and smoke to pass through. If the annulus space is too small, the fire-stopping material may not be able to expand properly, which can also compromise the fire resistance of the installation. The NEC and the manufacturer's instructions provide specific requirements for the size of the annulus space. For example, NEC Section 314.21 requires that the annulus space around boxes and fittings installed in fire-rated walls be sealed with a fire-rated sealant. The sealant must be applied in accordance with the manufacturer's instructions, and the annulus space must not exceed the maximum size specified by the manufacturer. It is important to measure the annulus space carefully before installing the fire-stopping material. This can be done using a measuring tape or a caliper. If the annulus space is too large or too small, the opening must be adjusted to meet the requirements of the NEC and the manufacturer's instructions. When dealing with perpendicularity, maintaining perpendicularity is crucial for cable and conduit penetrations through fire-rated walls. Perpendicularity refers to the angle at which the cable or conduit passes through the wall. Ideally, a cable or conduit should pass through the wall at a 90-degree angle. This ensures that the fire-stopping material can properly seal the opening and prevent the passage of fire and smoke. If the cable or conduit passes through the wall at an angle other than 90 degrees, it can create gaps in the fire-stopping installation, which can compromise the fire resistance of the wall. To ensure perpendicularity, it is important to carefully align the cable or conduit before it is installed. This can be done using a level or a plumb bob. If the cable or conduit is not perpendicular to the wall, it may be necessary to adjust the opening in the wall or to use special fittings that can accommodate angled penetrations. In addition to ensuring perpendicularity, it is also important to ensure that the cable or conduit is properly supported and secured. This is to prevent the cable or conduit from moving or shifting, which can damage the fire-stopping installation. When dealing with enforcement authority, it is important to understand that local code enforcement officials have the authority to enforce the requirements of the adopted codes, including the NEC and the FBC. These officials are responsible for ensuring that electrical installations are safe and compliant with all applicable codes and standards. If an electrical installation does not meet the requirements of the code enforcement official has the authority to issue a violation notice and to require that the installation be corrected. In some cases, the code enforcement official may also have the authority to impose fines or other penalties. It is important to cooperate with code enforcement officials and to address any violations promptly. Failure to do so can result in delays in the project and can also create safety hazards. If you have any questions about the requirements of the code, you should contact your local code enforcement office for clarification. Code enforcement officials can provide guidance on the proper installation of electrical systems and can help ensure that your project is safe and compliant. When dealing with UL standards, it is important to understand that UL, or Underwriters Laboratories, is a not-for-profit organization that tests and certifies products for safety. UL standards are widely recognized and respected, and they are often incorporated into built-in codes and other regulations. When a product is UL listed, it means that it has been tested and found to meet the requirements of the applicable UL standard. UL listing is a sign of quality and safety, and it can give consumers and building officials confidence in the product. In the context of fire-rated walls, UL standards provide specific requirements for the performance of fire-stopping systems. These standards specify the amount of time that a fire-stopping system must be able to prevent the passage of fire and smoke. UL standards also specify the types of materials that can be used in fire-stopping systems. When selecting fire-stopping products, it is important to choose products that are UL listed for the specific application. This will ensure that the products have been tested and found to meet the requirements of the applicable UL standard. The UL Fire Resistance Directory is a comprehensive guide to UL-listed fire-stopping systems. The directory provides information on the types of products that are listed, the fire ratings of the systems, and the installation requirements. This is a valuable resource for architects, engineers, contractors, and building officials. When dealing with approved methods, in the absence of specific guidance in the FVC or NEC, the code enforcement official may consider other approved methods for fire-stopping penetrations. These approved methods may include manufacturers' instructions, engineering judgments, or other recognized standards. Manufacturers' instructions provide detailed information on the proper installation of fire-stopping products. These instructions should be followed carefully to ensure that the fire-stopping system is installed correctly and will perform as intended. Engineering judgments are evaluations of fire-stopping systems that are performed by qualified engineers. These judgments are based on the engineer's knowledge of fire science and engineering principles. Engineering judgments can be used to evaluate fire-stopping systems that are not specifically listed by UL or other testing laboratories. Other recognized standards, such as those published by ASTM International or the National Fire Protection Association, can also be used as guidance for fire-stopping penetrations. These standards provide information on the properties of fire-stopping materials and the proper installation techniques. It is important to consult with your local code enforcement official to determine which approved methods are acceptable in your jurisdiction. The code enforcement official can provide guidance on the proper installation of fire-stopping systems and can help ensure that your project is safe and compliant. When dealing with recommendations for surface-mounted boxes for cut-in boxes in rated walls, one can consider having the contractor install surface-mounted boxes that can be securely fastened to the studs. Surface-mounted boxes are typically easier to install and can provide a more secure connection than cut-in boxes. Surface-mounted boxes are mounted directly to the surface of the wall, rather than being recessed into the wall cavity. This makes them easier to access and maintain. Surface-mounted boxes are also less likely to damage the fire rating of the wall, as they do not require a large opening to be cut into the wall. When selecting surface-mounted boxes, it is important to choose boxes that are rated for the same fire rating as the wall in which they are being installed. This will ensure that the boxes do not compromise the fire resistance of the wall. It is also important to choose boxes that are large enough to accommodate the wiring and devices that will be installed in them. The NEC provides specific requirements for the size and installation of surface-mounted boxes. When dealing with UL-approved fire-stop systems for penetrations through fire-rated walls, require the contractor to implement a UL-approved fire-stop system or to meet the specific requirements of a defined UL system number. UL-approved fire-stop systems are designed to prevent the passage of fire and smoke through penetrations in fire-rated walls and floors. These systems have been tested and certified by UL to meet specific performance requirements. When selecting a UL-approved fire-stop system, it is important to choose a system that is appropriate for the type of penetration being protected. There are different fire-stop systems for different types of penetrations, such as cable penetrations, pipe penetrations, and conduit penetrations. It is also important to choose a fire-stop system that is compatible with the materials being penetrated. Some fire-stop systems are not compatible with certain types of materials, such as plastic pipes. The UL Fire Resistance Directory provides information on UL-listed fire-stop systems. The directory includes information on the types of penetrations that the systems are designed to protect, the fire ratings of the systems, and the installation requirements. It is important to follow the manufacturer's instructions when installing a UL-approved fire-stop system. This will ensure that the system is installed correctly and will perform as intended. When dealing with sealing in UL space, it is important to verify that the annulus space around the penetration is thoroughly sealed with fire-stopping materials, adhering to the required limits as specified by the approved system. The annular space is the gap between the penetrating item, such as a cable, pipe, or conduit, and the edge of the opening in the wall or floor. This space must be properly sealed to prevent the passage of fire and smoke. Fire-stopping materials are specially designed to resist the passage of fire and smoke. These materials come in a variety of forms, including sealants, putties, foams, and wraps. The choice of fire-stopping material will depend on the size and shape of the annular space, the type of penetrating item, and the fire rating of the wall or floor. It is important to follow the manufacturer's instructions when installing fire-stopping materials. This will ensure that the materials are installed correctly and will perform as intended. The manufacturer's instructions will specify the required depth and width of the fire-stopping material, as well as any special installation techniques that are required. It is also important to inspect the fire-stopping installation regularly to ensure that it is in good condition and that it has not been damaged or compromised. Damaged or missing fire-stopping material should be replaced immediately to maintain the fire resistance of the wall or floor. The selection and installation of boxes, fire-stopping materials, and cable and conduit penetrations in fire-rated walls are critical for ensuring the safety of buildings and their occupants. By following the requirements of the NEC, the FBC, and UL standards, electrical contractors can help to protect buildings from the spread of fire and smoke.